Hello students, welcome to Eduauraa. I, Mr. Deepak Pote, your physics mentor, talking about the linear simple harmonic motion. Linear simple harmonic motion with the form of an example. Where to the example, we talk about one rigid support and we are talking about one surface which is a frictionless surface. Right now for time being, to get our derivation, to get our concept, to just analyze, we talk about this surface being frictionless. It is negligible or we are right now neglecting it. On this surface, we are having a block, an object, a substance which is having a mass small m. And this block is tied to a spring. So we have a block of mass m on a frictionless disc, tied to a rigid support with the help of a spring. And right now it is located at its mean position. What we do to talk linear simple harmonic motion, we stretch the block to the right hand side. So when the block is stretched to the right hand side, we can see that there is a displacement which is to the right hand side. Let us say that displacement is x. But when it goes to the extreme position, since the spring will get stretched, don't you feel that the stretched spring will try to restore, will try to rebuild, will try to re-come again at its mean position? Why? That's the condition. Linear simple harmonic motion. It has to cross back its mean position. So it is trying to restore back its to mean position. So this force henceforth will be called as the restoring force. Catch the word. What is the force called as? Restoring force. What is the restoring force? The force which is trying to get it back to its mean position. So what is the displacement? Extreme right hand side x. Where is the restoring force? Trying to bring it back to its mean position. So what is the formula we get? F is proportional to x. Why? We talk with respect to magnitude. With respect to direction, F is equal to minus x, where x is the right hand side movement, F directly proportional to x, where the displacement is to the right hand side and the force is acting towards the mean position. Mathematically, F equal to minus kx. What happens further? The object will come back to its mean position. But when it comes back to its mean position, it has generated that amount of velocity. So when it comes to the mean position, the velocity is maximum, but there is no acceleration. And hence, because of this velocity, it will continue further the movement towards the left hand side. And it goes to the other extreme position. If it goes to the other extreme position, once again the displacement will be same x, reaching to the maximum extreme position. What happens to the velocity? Velocity becomes 0. And what will the force do? The force will again try to restore it back to its mean position. So this is an example of a linear simple harmonic motion where to the mean position it is stretched, goes to the displacement x, restoring force will try to bring it back to its mean position. Due to the velocity, it gets compressed and goes to the extreme left hand side where once again the displacement is x and the restoring force will again try to bring it to the mean position. So linear simple harmonic motion where the body is moving straight line. Right now, we'll wind up the session over here. Most important, keep studying, stay home, be safe, and please keep on liking Eduauraa. Stay connected. We'll be coming back soon with the further content of our lecture. Thank you. God bless you. Stay blessed.